Okay, so now we have what's called the factor theorem. And the factor theorem says k is a 0 if and only if x minus k is a factor of f of x. Okay, now that might be confusing, but it says two things. If you know a number is a 0, then you know a factor. So if 2 is a 0, then x minus 2 is a factor. Okay, so that's important. We're going to use that later on. But it also goes the other way. If I know, say, x minus 5 is a factor, then I know 5 is a 0. Okay, so that's what the theorem says. And now we'll show you an example. It says show that x plus 2 is a factor of, and then they give me this polynomial here. And they didn't write it as a function. I don't know why they didn't write the polynomial as a function, but that's okay. All right, so if we know x plus 2 is a factor, then what I can do is I can synthetically divide by negative 2. So what I'm going to do is I'm going to divide this polynomial by x plus 2. So put negative 2 in the box. Remember, it's going to be the opposite sign. Pull off the coefficients, 1, negative 6, negative 1, 30. And then I'm going to go ahead and do this division. So bring down the 1, negative 2, negative 8, 16, 15, and 15 times negative 2 is negative 30. And we get 0 for the remainder. Now you might be saying, well, why'd you bother doing that? We already knew that it was a 0 because of the factor theorem that we just had, right? Okay, so we knew this. We knew this. We knew that was going to happen, which is nice. So if you did the synthetic division, you can say, oops, I did something wrong. Okay, so we know that x plus 2 is a factor, or in other words, it's dividing the polynomial evenly. But here's the exciting thing. The quotient is x squared. Remember, you have to go down a degree. Minus 8x plus 15. That's the quotient. So I can find the other factors, because that's quadratic, I can factor it. Or use the quadratic formula. It says find the remaining factors, use the factors to determine the zeros of the polynomial. Okay, so let me go through this problem in pieces here. Show that it's a factor. We did that when we found it had a 0 remainder. So I don't know that I've really talked about that in the other videos, but if x plus 2 is going to be a factor, then it has to have a 0 remainder, okay? And that's implied in the factor theorem. Okay. And then, so we did that. Now we got to find the remaining factors. So we can find those by factoring this polynomial we have. And it factors into x minus 5 and x minus 3. So that one nicely factors for us. And then it says use the factors to determine the zeros of the polynomial. So in other words, if I had this polynomial right here, and I said it's x cubed minus 6x squared minus x plus 30, and I wanted to set it to 0, I wanted to find the zeros of that polynomial. In the past, we didn't have techniques to do that for a higher degree. It doesn't factor just by itself. But because we know x plus 2 is a factor, we were able to get this polynomial as the quotient. So we divided the original polynomial by x plus 2, we got the quotient. So now our polynomial can be written in that binomial times the trinomial. But the great thing is, we know that that trinomial factors x minus 5 and x minus 3. And so now you can use the zero product principle to find the zeros. The zeros will be negative 2, 5, and 3. I don't really care what order you write them in, but those are the zeros. Okay?